Hello, my name is Craig, and I'm from a small town just east of Durban called Pietermaritzburg in South Africa. And today I'll be talking to you about the properties of sound, which are propagation, amplitude, frequency, and timbre. Propagation is the way in which waves travel, and generally, apart from electromagnetic waves, waves need to travel through a medium. When we're talking about sound waves, most often we're talking about sound waves traveling through the air. Waves travel at different speeds through different materials, but generally sound travels through air at the speed of 340 meters per second, or 1 kilometer every 3 seconds. Generally, that is the constant speed, but it can be influenced by things like the air temperature and air pressure. The most important part in audio production where we use propagation is to create a sense of space in our music. And if we want to get, for example, the effect of recording in a large hall or a large space, or if we want to make it sound like we've recorded in a small, tight space. Amplitude is the extent of the wave, or how wide a wave is moving. In contrast to transverse waves, where the propagation is perpendicular to the direction of movement, sound waves are longitudinal waves where the propagation is parallel to the direction of movement. And so how we measure amplitude in sound waves is the compression and rarefication of the air as the sound wave moves through the air. We as humans perceive sound as loudness, or how quiet or loud a sound is, and that's also influenced by what the frequency of the sound is and also how long the sound is. We measure amplitude by using decibels. Now, decibels are a logarithmic unit that we use to measure physical quantities, and we measure sound in two different areas, either digitally or in the air. If we're measuring in the air, we measure sound pressure level, and decibels are a relative measure. So when we're talking about the decibels of sound in air, we're comparing it to the softest sound that we could hear, and then that's set as 0, and then anything louder than that obviously then gets a positive value. The converse is true for when we're recording digitally, and decibels are then done according to full scale, where the full scale measurement is set at 0, which is the maximum or the loudest sound the device can produce without getting clipping of the sound, and then the measurements are then negative from that. Amplitude is important in audio production and mixing things, where we're balancing instruments relative to each other or panning, and the specific plugins that we use are things like gates and limiters. Frequency. Frequency is how fast a wave is vibrating, and it's our sense of pitch. So frequency is something that the computer measures, whereas pitch is something that we perceive. Frequency is measured in hertz, and 1 hertz equals 1 vibration per second. We as humans can hear or perceive frequencies of between 20 hertz and 20,000 hertz, but that also depends on your age and what sex you are. Timbre. Timbre is a collection of sound in multiple frequencies, and because when we do audio production, we generally work with whole sounds and not single frequencies, we generally tend to use the term timbre a lot more. It's basically what creates the quality of a musical note, sound, or tone. It's what makes sounds different from each other, in the way that you can play a C on a piano and you can play a C on a guitar, and even though they're the same frequency and the same amplitude, they still sound different. Generally, the same effects that affect frequency also affect the timbre of a sound, and those are things like EQs and filters.